In this video, we're going to take a look at a specific example that shows you what happens when you compose two functions that are inverses of one another. So suppose we have the function f that is a one-to-one function and that the point 3, 2 is in f. Then f of 3 is equal to 2. Since f is one-to-one, it has an inverse f inverse that is also one-to-one. And since the point 3, 2 is in f, then the point 2, 3 would be a point in f inverse. And so f inverse of 2 is equal to 3. So now let's find f composed with f inverse at 2. F of f inverse of 2 is f of 3, and f of 3 is 2. Notice that we started with 2 as the original input value, and we ended up with 2 as the final output value when we compose these functions. And now let's find f inverse of f of 3. F of 3 is 2, and then f inverse of 2 is 3. So again, the original input value becomes the final output value when we've composed functions that are inverses. Now, why is this true? Well, let's start with the point 3, 2 and think about the pairing. 3 takes you to 2 in f, but then in f inverse, 2 takes you back to 3. And so you can see that although this is just one example, that this would always be true. And so if you are asked to prove that two functions are inverses of one another, you're going to use this fact that f of its inverse of x will give me back the original x, and that f inverse of f of x will give me back the original x.